Here's the key for the additional practice problems regarding U substitution. If you haven't tried this already and you're looking for some guidance, then I would suggest that you watch how the first couple of problems are done and then try a few on your own while pausing the video to see if you are on the right track and you can check your work. The problems do get a little bit more difficult as we move down. With the first problem, our inner function is x plus 9. So we're going to make u equal to x plus 9. So that's our first step. Identify what u is. Identify the inner function. Check. Second step, take the derivative of u. So we're going to derive u, and the derivative of x plus 9 is 1, which we don't need to write, but I'll put it in there. Right? And then we are multiplying that by dx, because technically we have du dx over on this side, but we need the x term over on the right. So we move it over to the right. All right, so we have dx. It's there. All right, so we're going to sub dx out and du in. Okay, we're going to sub x plus 9 out. X plus 9 is equal to u, so we're going to sub that in. Now x plus 9 was raised to the 5th power, so u will be raised to the 5th power. So we have the antiderivative of u to the 5th du, which is a nice easy antiderivative from the previous practice, whether it's u to the 5th du, or x to the 5th dx, or t to the 5th dt. It doesn't matter what the variable is. The antiderivative rules all follow the same. So what do? We add 1 to the exponent, and we divide by that new exponent, and then we add in our arbitrary constant. Again, notice there's no antiderivative symbol anymore. This symbol says take the antiderivative. Once we do take the antiderivative, we should not write this symbol anymore. And again, this is our differential. The antiderivative of the derivative, they wipe each other out. That's why there's no longer a du. However, when we do take an antiderivative, there is the possibility for some constant after it. That's what the plus c represents. And our final step is we don't want our answer in terms of u. We want our answer in terms of x, because that's what the original antiderivative was in terms of. So we have to replace x plus 9 back in for u. So we have x plus 9 to the 6th power over 6 plus c. That is our final answer. And we know this is correct because if we derive this, we're going to get x plus 9 to the 5th. All right, let's do that really quick over here on the side. All right, we're going to take the derivative of 1/6, and then x plus 9 to the 6th power plus, and you can plug in whatever number you want here. You can leave it as c, or you can say, you know what, plus 8. All right, there's our, we want to derive this. We should end up with that. So when we take the derivative, we have a coefficient, so that's going to stay. And then we have an inner function to the 6th power. This is the chain rule. So derive the outer function. So the 6 comes down, keep the inner function. Right, but because we're deriving the outer function, which is our inner function to the 6th power, our new exponent is to the 5th. Right, and then we multiply by the derivative of the inside, the derivative of the inner function. The derivative of x plus 9 is 1. And then finally we take the derivative of plus 8. 8 is a constant, so it derives to 0. So we don't need to write the plus 0. We don't need to write the times 1. And the 6 and the 1/6, they wipe each other out. So what are we left with? X plus 9 all to the 5th power, which is exactly what we started with. So it checks out. Let's take a look at number 2. We'll put the rest of them on a separate video. With u, we have to identify our inner function, and the inner function is x squared plus 8. That inner function is being raised to the 4th power. So we'll make u equal to x squared plus 8. Now we need to derive this. The derivative of u is the derivative of of x squared plus 8, which is 2x dx. Now we have the 2x and we have the dx. So they are going to sub out. They're equal to du. So du subs in. Still have our antiderivative symbol. Instead of x squared plus 8 to the 4th, x squared plus 8 is u. So we'll have u to the 4th. So these two expressions are the same. This one is complicated and a little difficult to antiderive. This, through substitution, is much easier, and it's a nice quick antiderivative. Add 1 to the exponent, divide by that new exponent, and add in your arbitrary constant. Finally, replace u with the x expression. So we have x squared plus 8 to the 5th power over 5 plus c. And again, if you derive that, you will end up with this expression right here through the use of the chain rule.